two quantitative variables, interpolation and extrapolation. So when we have two quantitative variables that we think might be related, we usually make a scatter plot. So here we have the percent unemployment in a given metropolitan area versus the murders per 100,000. And there seems to be an uphill trend to this data. So we have an association. We can measure that association with correlation. So here I calculated the correlation coefficient. In a spreadsheet to make that calculation, it's just equals, start typing correlation, C-O-R-R, and I get the correlation coefficient. And then Y data, I'm doing murders for Y, and my X, comma, is percent unemployment. So I have a pretty high correlation here, almost 0.9. And so these points relatively line up. I can ask for a line on the graph. So to do that, I can edit my scatter plot, customize series, and ask to see the trend line. So kind of like in StatKey, I can see the trend line there. If I want the equation for the trend line, I have a couple of options. One is to go back to edit, and under customize series, after trend line, I can say label with the equation. And so it tells me the slope is 7.08, the y-intercept is negative 28.5, and I can also get r squared. Now remember, it's not r, it's r squared. So in the graph, they show r squared. That's called the coefficient of variation. I'll talk more about that later. So if we square this number right here, the 0.864 blah, 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 we should get 0.78748. They have slightly different meanings, but they're related. Not a big deal. Again, if this is the coefficient of variation, usually we want the correlation coefficient in this class, so that's r. So you can either take the square root of the number on the graph or just calculate it yourself. If you want more decimals for the slope than what's given here, you have to calculate them. So I'm just going to move this out of the way. Calculate the slope. Intercepts. So that's just slope. Y values, then X values. Same thing. Intercept, intercept, Y values, and X values. You got to get that order right, otherwise you get the wrong numbers. All right, so it's just giving me the same numbers the graph did, just with more decimal places. Usually we round to one more than the data shows. So the data shows to the nearest tenth, so we would round these to the nearest hundredth. Correlation coefficient is often to 3 decimal places. Sometimes we need more. Let's just clean this up. There we go. So interpolation means to make a calculation based on your model instead of looking at the actual data. These are each associated with a city, and here's the population of a city. I don't have a city with a population of exactly, say, 120,000, and so I could use my equation to calculate that. So let's just grab some of these numbers, and I think 2 and 1 is fine there. Let's get this into a drawing board to make a couple of notes about it. So the line, remember we call that y hat. So in this case, I've got y hat is equal to about 7.08x minus 28.5. Interpolation is to predict within the data. So within the data means having an unemployment rate between 5% and around 9%. And that's interpolation. And this is called a linear model here. It's not the actual data, it's a model for the data, and it's a straight line. So interpretation is to use the model to predict within the range of the data. So if I pick an unemployment rate of anywhere between 5 and 9% roughly, that would be interpolation. Extrapolation is to use the model to predict outside of the data. And again, I'm focusing on the explanatory variable, the independent variable, because that's x, and usually we start by plugging in x, but we could go the other way. So if I was going the other way, as far as murders go, I'd have to make sure I have murders per 1,000 between 0-ish and 40-ish. So it could go either way. So if I, for example, there's nothing, no data, it was exactly 7%, so I could predict with this the murder rate of a city that had unemployment of about 7% by just plugging in. So if I let x, color there, if I let x equal 7%, which in this case I would just write as 7, then I can make a prediction y hat by plugging in 7.08 times 7 minus 28.5. Let's get a calculator to figure out what that is. Remember, spreadsheet's calculator. So scroll up a little bit. All right, so maybe I'll come over here and do that. X versus y. So I was letting x equal 7. Y would just be equal to, I was using the rounded version, 7.08. So I'm not going to click on the number. I can click on that one. Minus 28.5. Based on the rounding numbers, I get a murder rate of about 21.06. So then I can explain what that means. So if a city has an employment rate of 7%, we predict murder rate of about, and I'm just going to go with the 21 murders per 1,000 people. So that's interpolating because the percent I picked to plug in is within the range of the given data. Similarly, if somebody says, well, what if there was a murder rate of 30 per 100,000? What do you think the percent unemployment would be, right? I could go backwards and do that, plug in y equals 30, and then solve to figure out what the corresponding unemployment rate is. So I could go the other way too. That's still interpolation because I'm within the range of the given data. Extrapolation would be to go outside of that. So for example, I do not have an unemployment rate of 10% here. That's outside of my data. And so using this equation to make a prediction outside of the data range, that's an extrapolation. And extrapolation is a little bit more dangerous because we really don't know what's going on out here. We don't have data to go with it. It could be that for cities that have higher unemployment rates, the murder rate's way higher, off the line, or way lower, but it may be on the line. We don't know. We just don't have that data. So extrapolation can be dangerous because you don't have supporting evidence related to the model. Now, 10% isn't too far out, right, for this line. That's somewhere over here. So I'm not too concerned about 10, but 15, 20% or unemployment rate of 1 or 2%, that's way outside of my data range. So I wouldn't be comfortable making a prediction with this model for numbers too far outside of the range. But interpolation,